Hello, welcome to the another lecture of control system. I am Mr. Prajit from Engineering College. Like to giving you some ideas about open loop and closed loop control system and the variants of control system correspondingly the respective expression for the same. We will provide that thing. On lecture 1, I discussed regarding the introductory thing. Now onwards it will be going on. What are the actual phenomena is going on and how to deal all those things based on the theory as well as mathematical concept. Okay. Now, here the classification of control system, and control system can be classified based on some parameters in the following ways, that is continuous time and discrete time control system. So obviously control system, continuous means the type of signal is continuous, that is analog signal. You can speak in continuous time control system, all the signals are continuous in time, sensing that is signal is analog signal. Obviously we can speak sinusoidal signal, whatever the continuous signal, it is valid for continuous time control system. In case of discrete time signal, that means there exists one or more discrete time signals, then we can speak about it is a digital control or discrete time control system. Now, CISO and MIMO control systems. CISO stands for single input single output and MIMO stands for multi input multi output control systems. So in case of CISO, that is single input single output control systems, have one input and one output, whereas for MIMO there will be multi input and multi output. So how to deal all those, that is a big issue with respect to control system. That thing we will see on successive modules and successive lectures. Okay. Now this is a very schematic of an automatic control system. Block diagram is highlighted. So here see the components are provided: error detector, controller, plant and feedback elements. These are the key components. Input is provided, that is my command signal. Again I am repeating, I can speak input or command signal with the help of error detector and taking help from the feedback signal which comes from the feedback elements. The error signal is generated and that signal will pass through a controller. Correspondingly actuating signal is generated and that actuating signal will pass through a plant and some which generates the output, and some portions of the output will pass through a feedback elements, okay, by which the feedback signal is generated, and again it will be maintaining to minimize the respective error. So these things will be going on. Since name itself signifies meaning automatic, so it stands, it does not need to rectify, does not need to minimize error manually. Automatically when the error is coming into prone or severe, it will automatically minimize by itself. That's why it is known as the automatic control system. So here the error detector produces an error signal which is the difference between the input and the feedback signal, and this feedback signal is obtained from the block, that is feedback elements, by considering the output of the overall system as an input to this block, and instead of the direct input the error signal is applied as an input to a controller. So that thing should be in your mind. Okay, now the controller produces an actuating signal. Just now I told you people, actuating signal which controls the plant, and in this combination the output of the control system is adjusted automatically, because that's why it is known as the automatic control system. So output of the control system is adjusted automatically till we get the desired response. Hence the closed loop control systems are also called as an automatic control systems. Here traffic light control system having sensor at the input is an example of a closed loop control system. See, that is another practical example. Okay. Now, what is the classical difference between an open loop control and closed loop control system? Here see, in case of open loop control, we see control action is independent of the desired output, obviously, and for closed loop control system, control action is dependent of the desired output. Obviously, from the looking diagram, from the principle, we can mention this comment. Open loop control system, obviously there will be no feedback path. In case of closed loop control system, feedback path must be present, then it is called feedback, otherwise it is not. and that's why open loop control system is also to be called as a non-feedback control system, and closed loop control is called as a feedback control system. Open loop control obviously easy to design, but closed loop control is difficult to design because complexity will arise high. Okay, open loop control system are economical obviously, since certain things are to be introduced in case of closed loop control system, that's why it is very much costlier. Open loop control systems generates the output can be inaccurate, whereas closed loop system generates accurate value due to the presence of this error amplifier or error detector, because it will automatically measures the respective output as well as the input, because it is feeding to, and try to minimize the error by which the desired response will generate in accurate way. Okay, now types of feedback. On lecture 1 just I mentioned the respective types of feedback, and here we will see in detail way how the expressions come for the positive feedback sense or the negative feedback sense. See, the right hand side diagram is highlighted. At first I will discuss about positive feedback. G is my forward path transfer function, H is my reverse or feedback path transfer function, and R of S and C of S is highlighted. R of S is nothing but is the Laplace transform of the input variable, and C of S is the Laplace transform of the output variable. And after that we will see what is transfer function, all those things. I hope in signals and systems you have a little bit knowledge regarding the transfer functions and the Laplace transform, because those things are very much essential in continuation to signals and systems, and parallelly it will be utilized in case of control system. Okay, so the positive feedback adds the reference input, that is R of S, and the feedback output. So the respective diagrams signifies, that is figure 1. Here see the total transfer function can be generated as T is equal to G by 1 minus GH. And you may ask me, sir, where is the derivation? Yes, derivation is available on some successive slides. It will be derived. I already derived it and it will be available up there. Where T is my total transfer function of the overall gain of positive feedback control system. G is the open loop gain, which is a function of frequency. Obviously, S is a function of frequency. S consists of sigma plus j omega. Omega unit is radian per second. So that things would be in your mind. Then those things will be very much easier to you people. And H is the gain of feedback path. That is also a function of frequency. Obviously, transfer function obviously a function of H of S. Actually, it will be G of S and H of S. Okay. Now, negative feedback. Here see, negative feedback reduces the error between the reference input R of S and the system output. Positive feedback enhances, that means increases. That's why I told you people positive feedback is also to be known as the regenerative type feedback. Negative feedback is known as the degenerative type feedback. Okay, and here the total transfer function can be written in the form as T is equal to G by 1 plus GH. See, if we are comparing equation 1 and 2 respectively, numerator does not change, whereas at denominator minus sign is replaced by plus sign in case of negative feedback system. That should be in your mind. Okay, so the G obviously that is my open loop gain. The respective two diagrams are remaining same, only the gain is changed. That is the actual scenario. So here G is the open loop gain, which is the function of frequency, and H is the gain of feedback path, which is also a function of frequency. Again I am repeating, those are H of S and G of S respectively, and S is nothing, that is sigma plus j omega. Now, what are the effects of feedback? Here see, the effect of feedback on overall gain. If the value of 1 plus GH, if I am looking the negative feedback expression, if the value of 1 plus GH is less than 1, yes, then the overall gain increases. In this scenario, GH value is negative, obviously, because the gain of the feedback path is negative. So that thing should be in your mind. Okay. Now, if the value of 1 plus GH is greater than 1, then the overall gain decreases. In this scenario, GH value is positive because the gain of the feedback path is positive. So that thing should be in your mind. Now in general, G and H already I told you that is the function of frequency, so the feedback will increase the overall gain of the system in one frequency range and decrease in the other frequency range. Okay. Now effect of feedback on stability, that is another thing. Effect of feedback on stability. A system is said to be stable if its output is under control. Again I am telling, a system is said to be stable if its output is under control, else it is unstable situation. Okay, so otherwise it is said to be unstable. So in equation 2, if I am looking this equation 2, that is T is equal to G by 1 plus GH. In equation 2, if the denominator value is 0, if the denominator value is 0, that means G by 0. Okay, that is obviously that is G of GH is equal to minus 1, then the output of the control system will be infinity. Yes, something by 0 is infinity, that is total transfer function, so the control system becomes unstable. So that is one vital point, all of you listen. Again I am repeating, when equation 2 I am discussing about that, here if I am making 1 plus GH is equal to 0, that signifies GH is equal to minus 1. So for that reason, the total transfer function for the negative feedback system becomes infinity. Okay, so stabilization is reduced and the system becomes unstable. So that is the boundary. So therefore we have to properly choose the feedback in order to make the control system stable. Similarly, if I am focusing on the positive feedback sense, there if I am putting 1 minus GH is, that is from equation 1 minus GH is equal to 0, that means GH is equal to 1, then also see the total transfer function becomes infinity. That means then again it is becoming unstable mode. Okay, so that thing should be in your mind. Then you can design the respective controller circuit. So whatever things I am telling to you people, that should be in your mind. In continuation to control systems, the knowledge of feedback connections are very essential, and what are the performance of feedback and what are the effects of feedback with respect to the overall gain, stability, that is very essential. Then only you can see that thing is very much easier to you, otherwise you have some puzzle. So these are the respective assignment is given to you. Briefly explain about the block diagram of the automatic control system, differentiate between an open loop and closed loop control system, and what are the effects of feedback on overall gain and stability of the given system. And these are the respective references. Already I took help from these two books, and you can study from any kind of books, and that's all for today.